Hey guys, today we're going to study natural logarithms, and you're going to find that natural logarithms are very similar to regular logarithms, with just a slight differentiation. The logarithm with base e is called a natural logarithm. The natural logarithm is denoted as ln x, and the ln key is beside the 4 on your calculator. And there are two important function values, ln of 1 is 0, and ln of e is 1. So we're going to use that information to use our calculator to find these values. So e squared is second ln 2, 7.3891. Second ln negative 1.3, 0.2725, ln 4, and we're rounding to 4 decimal places, 1.3863, and ln 0.05 is negative 2.9957. Get you familiar with those keys. You can write an equivalent base e exponential equation for a natural logarithmic equation and vice versa. So as you look at e to the x equals 5, I want to know a value of x. So I do x ln e equals ln 5. Bring down the exponent ln on both sides. You know you have to use ln because e is in your equation. We know that ln of e is 1, so x equals ln 5. If you just have one ln, then each side becomes an exponent of e. Again, e and ln can cancel each other out, and x is approximately e to the 0.6931 power. Since the natural base function and the natural log function are inverses, these two functions can be used to undo each other. So e to the ln 7 is just 7, and ln e to the 4x plus 3 is just 4x plus 3. So I just keep the rule. If I see e and ln together, they cancel each other out. Equations involving base e are easier to solve using natural logarithms than common logarithms. All of the properties of logarithms that you've learned apply to natural logs. So you don't have to relearn new properties or learn new properties. You just keep in mind everything that you've learned up to this point. So the first thing we're going to do is add the 7. We're going to bring down, actually we're going to divide by 5 first. So we're going to bring down that negative x. ln e equals ln 9/5. There's your 1. Negative x equals ln 9/5. Type in your calculator ln 9/5. Enter. Divide negative 1. Enter. And you should get negative 0.5878. This should look familiar. When interest is compounded continuously, the amount A or Y in an account after T years is found by using the PERC formula. P is the principal amount, and R is the annual interest rate as a decimal. So suppose you deposit $1,000 in an account paying 5% annual interest, compounded continuously. What is the balance after 10 years? Again, this is all review. So y equals 1,000 e to the 0.05 times 10. Type it in exactly as you see it. Use your calculator and you should get $1,648.72. How long will it take for the balance to reach 1,500? We've done one like that as well. So I'm going to show you how to do that without a graph. So 1,500 is your final amount. You still have your initial amount and you still have your interest rate. So divide by 1,000. ln on both sides, bring down your exponent. ln e is 1. Divide by 0.05. And t is 8.11 years. As you can see, this is going to give you a very definite answer, whereas the last time we did that, we had to say between 32 and 33 years. For example, 6, you have 1 ln, so both sides become the power of e. So e to the ln 5x equals e to the 4th power. 5x equals e to the 4th power. Divide by 5, and x is 10.9196. I hope you find that this is a pretty easy section, especially since you can use those log properties for natural logs. As always, let me know if you have any questions. I hope you have a great day.